Awesome. I'll go ahead and jump in. Like Kirby said, I've got about a little under 30 minutes to chat, and I'm hoping to not take that much time at all. I decided to do something a little different for this Mind Garden today. I decided to kind of go over some of the high-level concepts of a book that I have finished reading about software design. The book is called A Philosophy of Software Design, so the talk is a synopsis of a philosophy of software design. There's some opinions in this book that I don't necessarily agree with, some that I do, and my goal is just kind of present the information in this book in a very factual manner and give everyone else the opportunity to form their own opinions, and hopefully we can start discussions about better ways to design our systems here at Neighbor. So without further ado, the book is called Philosophy of Software Design by John Ousterhout. I think it's important to talk a little bit about the achievements of the author to kind of validate the credentials that an author has about a book or has when they write a book. So John is the creator of the TCL scripting language. I found out that you can pronounce it tickle. That was an interesting fact. He's also the creator of TK or Teak, which is a platform-independent widget toolkit. These were created back in the 80s and the 90s, but anyone who is familiar with Python and the TK Inter or Tekin, I can't even pronounce it, GUI library, those use Tickle and Teak on the back end for creating GUIs. So it's a pretty prolific scripting language and toolkit. He also led the research team that built the very first log-structured file system, which that's a pretty amazing kind of invention because we use log-structured everything going forward. A lot of our databases are log-structured. And since 2008, he has been a professor at Stanford University. So what was John's motivation for writing a book on software design? First off, the book is 184 pages, so it's not that large in the realm of engineering books. There's books like Domain-Driven Design, which is upwards of 500 to 600 pages. There's other books that are upwards of 400 to 500. Anything that is published by O'Reilly tends to be 500 pages or more. His motivation for writing this is he created a course at Stanford, which is CS 190. It's a software design course. And his course was to help teach students how to design software systems. Because for those of you who remember your time in school, if you had formal software engineering or computer science training, the courses tend to be go build a project in the course of a week or 2 weeks, move on to the next one, build the next one, and just kind of keep jumping from project to project. And even if you did build a large or semester-long project, you're usually racing to meet additional requirements and don't really have to care about code hygiene. So the purpose of his course was to give students the chance to learn to iterate on their designs while also having to revise existing code functionality. As well as he would sprinkle in code reviews. He would read each of the milestones, all of the code that the students wrote. So this wasn't a large class. He could only handle 50 to 60 people at a time, split into groups of 3 to 4. I mean, that's thousands of lines of code he would have to read every couple weeks. And after running this course for multiple years, he finally decided to put together a book based on his own professional experience as well as his experience teaching students how to design software systems. So that's kind of a background on this book. I chose to read it because I was trying to understand a little better how to structure systems and write better code that's scaled as we follow this iterative approach of improving software. And this was one that I found recommended. So without further ado, we're going to jump in. One of the first topics that John talks about in this book is complexity. And this is one of the quotes that I pulled from the book that I think is pretty interesting. He says, "The greatest limitation in writing software is our ability to understand the systems we are creating. The larger the program and the more people that work on it, the more difficult it is to manage complexity. Good development tools can help us deal with complexity, but there is a limit to what we can do with tools alone. Simpler designs allow us to build larger and more powerful systems before complexity becomes overwhelming. And so he talks about, where's my text? Oh, there it is. He talks about kind of 3 symptoms of complexity in systems. The first one is change amplification, where any simple changes to a system require code changes in many places. If you want to touch one part of the system to add a new feature, you actually end up touching many different places in the code. He also talks about how another symptom of complexity is cognitive load. It's how much a developer needs to know to make changes. We often talk about this as tribal knowledge or as the bus factor of an individual. It's just how much you need to know to work productively within a system. And then the final symptom he talks about is unknown unknowns. It's not obvious what needs to change, and it's not obvious what the impact radius of a change will be. And he makes the statement that it's not possible to completely eliminate all complexity. It is only possible to mitigate and reduce its impact. So moving forward, he kind of talks about why we end up with this level of complexity in our systems. And so the first thing he talks about is tactical and strategic mindsets when it comes to programming. He defines tactical programming as programming with the intent of getting something working. You move as quickly as possible at the expense of a little complexity or overhead, and it's eventually the summation or the culmination of all of this moving quickly at the expense of complexity that leads to a complex system. He kind of berates the idea of an MVP in the way we understand it, where you build things to get something shipped at all costs, because you end up making compromises along the way that make future maintenance of a system much more difficult. And so his bold statement is tactical programming makes it nearly impossible to produce a good design. And his even more triggering statement is agile and test-driven development only encourages tactical programming, because you're not taking the time to thoroughly think about what you're programming, designing it from a higher level view than just getting it written as quick as possible. So the flip side of this is strategic programming. So in strategic programming, it's not acceptable to introduce complexities to get tasks finished faster. You focus on producing a great design that also happens to work. So it's kind of the inverse of with tactical programming, you're trying to get something working, whereas with strategic programming, you're focusing on a great design that also works, thereby eliminating the complexity that comes from taking shortcuts. And then this also, by strategic programming, you continually make small improvements to beat back system complexity. And so his statement is strategic programming requires an investment mindset. You're putting up an additional percentage of work up front so that down the road you are in a better place when it comes to managing complexity. And so he talks about how technical debt is often used to describe problems created by tactical programming. With tactical programming, you're borrowing time from the future so that development will go faster now, but more slowly later on. And then he finally states that once a code base turns to spaghetti, it is nearly impossible to fix. You will probably pay a high cost for the life of the project. And obviously, he's talking about really large systems when he's talking about strategic versus tactical programming, because he talks about how tactical programming is the compounding effect of these compromises that have been made when building and designing a system. And so it's easy for, just using a simple example, you can write a 1 to 2 file like Lambda, and no one's really going to care about complexity, but once you get to a system of significant size and detail, that complexity compounds and eventually can become crippling if the complexity is not managed correctly. So he talks about, after talking about these different symptoms of complexity and talking about the different mindsets developers has to have, he then dives in and talks about how the students that he observed in his course, the ones that were most successful in future iterations of their project, were able to intuitively focus on a few principles that allowed their systems to be more modular and extensible in the future. And one of those things was the building of deep modules that have simple interfaces. So he defines deep modules as modules that hide the complex functionality from external users of the module. So for example, if you are to build a module, it's not necessary for a user to understand the actual implementation details of a module. They just need to understand what the module is trying to do, as well as how to leverage the interface to perform the desired result. He talks about how deep modules, hold on, sorry, trying to read my notes. That's a really bad sentence right there. So he talks about how oftentimes we end up with what he calls shallow modules. In other words, modules that do very little but require a lot of understanding of what they do. It comes when we try to specialize our modules. So he talks about, to create these deep modules, you need to avoid the over-specialization of modules. Instead of writing modules that do one thing and one thing only, we need to focus on generalizing modules. We should try to eliminate special cases as much as possible, and we need to avoid separating functionality for the sake of separation. Larger modules are okay if they contain related complexity. So he argues that modules should actually be extremely deep, right? It's okay to have these massive modules that do a lot of things as long as they do what they're supposed to do well and they're not specialized. He says a shallow module is one whose interface is complicated relative to the functionality it provides. So he used an example. I didn't put it in here and I wasn't going to talk about this, but he kind of talks about Java as a programming language. If anyone's ever used Java, there's many different ways that you can actually open a file, right? You can open a file without a buffered stream, and when you do that, you then have to instantiate a buffered stream class that you then pass in your file, your open file descriptor to, and then to get additional functionality, you can pass these things into additional classes. You end up chaining these classes to get the desired functionality, and he's saying that that's a symptom of shallow modules in the Java language. That instead you should just have a single module that opens and allows you to read a file that offers buffering, because who doesn't want to have buffered file streams as part of reading a file, right? It's a very slim use case where you actually want a special case of not having buffered file streams. And so he talks about how you should combine all that functionality together and make more general purpose modules that do its common case well, right? And so that's when he talks about simple interfaces. A simple interface consists of everything a developer working in a different module must know to use the given module. If I go to do something and I happen to use a module from some other part of the code, I shouldn't have to understand the implementation. I should be able to pull it in and use it according to how you would expect it to function. He talks about how you should design to make the common case as simple as possible. An example of this is the AWS SDK for Go. I don't know how many of you guys have used this, but AWS did a really good job with this SDK because it would be possible for them to create the instantiation of this. You could call it class, you can call it service, by requiring you to pass in a ton of parameters to make it work. Your AWS access key, your ID, maybe the role you're trying to assume, etc., just to even initialize it in the first place. However, the AWS SDK for Go just assumes it's going to find credentials in your environment. And if you do nothing else, it's still going to work under the assumption that the common cases that everyone has nvar set with their secret key and access ID. And so, but then you can provide additional parameters for these more specialized cases. And so it's built in such a way that it does the base case, the common case extremely well without requiring additional developer overhead to do more complicated things. So moving on from his conversation about deep modules versus shallow modules as well as simple interfaces, he talks about how complexity often comes when we fail at information hiding, which leads to information leakage. In his first case, obviously this is a little spiel that modules should be deeper, but he talks about how making a module deeper can reduce information It can improve information hiding, therefore reducing information leakage. If the common case is as simple as possible, doesn't require additional information from a user, you can reduce how much information is actually leaking outside of a module. If you focus on making modules general purpose, then there is less information needing to be known by a developer, as well as modules should do the right thing without being explicitly asked. It should be predictable. It should do what you would expect it to do. And then you should avoid information pass-through. I'm sure we've all seen scenarios where you have a function or a module that takes in a set of parameters and then just proceeds to pass it straight through to another module without doing any sort of decoupling of those interfaces. And he says that avoiding information pass-through is one of the information pass-through is one of the more crippling ways that you create these dependencies between modules. For example, taking a custom structure or type that is not ever used within a module and then just passing it straight through to another module, you end up creating this coupling now between a custom type, this intermediary module, when it's only ever being used by the final downstream module. He then talks about how information leakage. Matt.
Did he offer an alternative?
No, so he did diving deeper, he did talk about how there are some cases where it's okay, like using a decorator type pattern is okay, but there's generally a way around that. He really just says
like
you should
you're doing something wrong.
You're doing something wrong. You probably don't need that intermediary function, and he said his solution is you either have kind of cross the concerns of the two modules, and you should just combine them if you're passing something through to another module, or you need to find a way to decouple them where information and types aren't needed between the two.
I just find it interesting. We had the exact same conversation when we read the microservices book and its information hiding section.
Yeah.
It seems like we were able to. It just seems like there were some hard problems that were just hard.
And I think that's a good point, right? There's some things that are hard to avoid because of how complex systems grow to be, and oftentimes. This is me just stating, he thinks his philosophy is that when you do end up doing kind of these pass-through operations, you've missed a step in your design, right? You need to take that code smell and kind of revisit it. And he talks about how you sometimes need to look at your design a couple times, right? Your first design is oftentimes going to be the bad one, and you should revisit it and try it in a completely different way to see if you can avoid those code smells. I don't know, did you have a solution or a thought?
No, I don't. I think that's like information hiding is one of the hardest things to actually achieve.
So Brian, you got 10 minutes.
Yeah, we're gonna get through this.
I wonder if we can just get through it and then maybe ask questions.
We'll get through it. We're pretty close to finishing anyway. So one of the other interesting concepts he talks about is temporal decomposition when it comes to information leakage. He talks about how the ordering of steps is broken between modules, right? He talks about how in these classes of students, one of their projects is they have to create a text editor, right? A simple text editor that allows you to modify text in a file, be able to insert, delete, etc. And how oftentimes you would see students create a class for reading a file, a class for writing a file, a class for doing all these different kind of independent operations. And it was really important when using these classes, the ordering in which they were invoked. And he mentions that that's a smell that there is some sort of information leakage. You should just combine your file operations into one single class with functions for reading and writing. That way you're not relying on the ordering of your invocations of different function methods, class methods, etc. So he says that you can avoid this temporal decomposition by focusing on knowledge that's needed to perform each task, not the order in which tasks occur. So when you're trying to decompose your program into modules, don't focus on the ordering of things, focus on related concepts and where you're actually going to need information. And he really loves this, just bring common code together. It will improve abstraction to make the common case easier for an unfamiliar developer. So moving forward, his final point that I wanted to point out is simple naming. He talks about how complex names or difficulty naming things is a code smell. If you have a hard time naming a variable, a function, a class, a struct, anything like that, you might be struggling with the level of abstraction that you've chosen. And so this could lead to overcomplicated interfaces and shallow modules because you're trying to do too much or you're trying to do unrelated things in one place. So he talks about how consistent naming leads to less complexity, and then simple names is equal to simple functionality. It's easier for developers to grok the purpose of the code when the names are very indicative of what the code does. And so his final statement, his conclusion of the book is, poor designers will ultimately spend most of their time chasing bugs in complicated and brittle code. And so if we do all we can to actually be good designers, the hope is that we spend less time chasing bugs, less time fighting brittle code, and more time actually iterating upon the designs and code that we have written. And that is the end. That was my attempt to distill 180 pages in the span of 25 minutes.
And you did it. We got 7 minutes for questions.
In the beginning, you mentioned you agree with something and also disagree with a few things.
Mm-hmm.
What are those?
That's a great question. So I think the big one, at least in what I talked about that I disagree with, is probably the generalization of modules. He talks about how when you take a module and instead of solving for kind of special cases, you solve the general purpose case. He said that's easier. And I think my personal opinion is actually really hard to solve and break problems down into a general purpose scenario. Because you end up with a lot of additional edge cases that you need to find essentially some way to either eliminate as a business requirement, or you need to find ways to essentially enhance the outputs of the general case to make it usable in special cases. Yeah, Garrison.
I'm curious whether the author said anything about choosing which one should be like the base or like the default generalized path, you know, like if there's several different code paths with these edge cases, how do you decide which one should be like, this is the correct normal way to do it?
Yeah, he didn't say anything about how to identify what's the common case. He was kind of implying that you should know already as the system implementer, right? What am I spending 95% of my time coding or supporting, and what's the other 5%? He did mention that if you find yourself using like a dispatcher pattern, which is very similar to like the pass-through conversation that we had, where you're taking in a set of arguments, then you're passing them just on to something else, but you're doing it based off of like a flag that determines, like in a case switch statement, which function you're passing it off to. If you're doing something like that, you're probably able to easily identify what your common path is. And even said like using a dispatcher pattern is not bad because you're essentially creating a function that allows you to handle those special cases.
A thread that was through some of these that I thought was good to illustrate was, think about it from the perspective of a developer who's not familiar with the system.
Yeah.
Right? Don't create traps for them or landmines, right? And say, if I were thinking about this to begin with, what would I expect? What's the intuition about what should happen based on the naming of this module and what its functionality is? And you saw that a couple of times throughout here, and I think that's, when it comes to Rails, the problem there, I would say it's a problem, but Rails already has an architecture for most cases, right? It says this is the idiomatic way to do things, so you're not really thinking about how to design a Rails system as much as you're thinking about how to build a Rails system to match your business case, right? Or the other way around, to have your business case match the Rails architecture. Yeah. So it may not actually be as relevant in Rails. That's all we got time for. Thanks, Brayden.